Welcome to the AP Calculus AB 2013 Question 2 tutorial with Sayara Nava and Melissa Morales. This question will be testing your knowledge on how to use your calculator, analyzing maximum and minima, and derivatives. Let's take a look at what we're given first before we go over the questions. We are given 3 pieces of information. The particle moves on a straight line for 5 units of time. We are given the function of velocity relative to time. We are given the initial position. S of 0 is equal to 10. Now question A asks us to find what times from and including 2 to 4, where speed is equal to 2. First, we must remember that speed is the absolute value of velocity, so this gives us 1 point. Absolute value of velocity is equal to 2. Now, we need to graph v of t and y equals 2 and negative 2, because those are our desired speeds. From here we can see 5 points of intersections with our desired speeds. Now we need to set our x minimum to 2 and our x maximum to 4 for our desired results. This ensures that we don't get anything outside of our domain. Our points are narrowed down to 2 results. Now, we analyze the graph for intersections and take those 2 points as our answer. t equals 3.128 and t equals 3.473. This gives us 1 easy point. Now that we're done with A, let's move on to B. Question B asks us to write an expression involving an integral that gives the position s of t. Use this expression to find the position of the particle at the time t equals 5. In this problem, we need to recall the function that gives us velocity, v of t, and our initial position, 10. To find our position at a set time, we integrate v of t and add our position at 0. And the function s of t. This gives us 1 point. Now, we need to plug in our desired time, 5. And now, we solve for another easy point. S of t at time equals 5 is negative 9.207. This nets us another point. Now that we're done with B, let's move on to C. And C asks us to find all the times from 0 to 5 at which the particle changes direction, and to justify our answer. For starters, we need to find times where velocity changes from positive to negative, or negative to positive. This is generally in the area at which velocity is equal to 0, so v equals 0. This gives us 1 point. Now, we need to graph v of t and locate the x-intercepts. We can see that the velocity intercepts at the x-axis at 0.536 and 3.318. This is where it changes direction. Now, we need to justify our findings. We see that on the graph, v of t changes from negative to positive at t equals 0.536. We also note that v of t changes from positive to negative at t equals 3.317756. We say, in conclusion, the particle changes direction at 0.536 and 3.318. This nets us 2 points for the whole justification. Now that we're done with C, let's move on to our final question, D. Question D asks us, is the speed of the particle increasing or decreasing at time equals 4? And to give a reason for our answer. Now we need to recall that if the sign of the velocity match the sign of the acceleration, our particle is speeding up. If they're opposite, our particle is slowing down. So, the solution is to take our function v of t and take the derivative to get acceleration. Now, we plug in our desired time for v of 4 and a of 4. v of 4 is negative 11.476. a of 4 is negative 22.296. We see that our velocity is negative, as well as our acceleration. So we say that the speed is increasing at t equals 4 because acceleration and velocity share the same sign. This nets us 2 points. Now we are completely done with 2013 question 2. Points possible total are 9 points.